Tomorrow we're going to have our fraction checkup, and so today I wanted to review all operations with fractions and clear up any confusion if there was any. So to start out, we're going to do some problems where we are multiplying fractions, and I wanted to remind you of the song that we had been singing, which goes like this. It goes, multiplying fractions, no big problem, top times top over bottom times bottom. Part of this is going to be on your checkup, so I wanted to include it today so that you realize that when you have a direction that you fill in the blanks for, the next couple of problems are going to follow that direction so that we don't confuse what operation we're supposed to be doing. So that means when we go to, we're going to apply that top times top and bottom times bottom. But please notice that the directions say to put our answers in simplest form. So when I look at this first one, I'm first going to look to my diagonal to see if there's anything that can go into 5 and into 3, and there's not. I cannot reduce that one. So then I look to the other diagonal. There's nothing that goes into 1 and 4, so now I can follow my rule. Top times top, 5 times 1 gives me 5. Bottom times bottom, 4 times 3 gives me 12. So the correct answer is 5 over 12. When we go to the next problem, we're going to look to our diagonal, and you'll notice that they're both 4s, so 4 goes into both of them one time. So we're going to reduce those to 1 to make our lives a little bit easier with our multiplying numbers. Then I look to 7 and 9, and there's nothing that can be reduced from these, so I'm going to do top times top, which will be 1 times 7, over bottom times bottom, which is 9 times 1, and our final answer is going to be 7 over 9. On this next one, you'll notice that the fraction on the number on the left is not a fraction, so we need to make it a fraction by putting it over 1. So our new problem is 2 over 1 times 3 over 7. I like to rewrite it just to make sure everything's even. That's just me, but you can do it how you want. So when I look at the 2 and 7, there's nothing that can be reduced. So now I look at the 1 and the 3, and since there's nothing that can be reduced, I'm going to do top times top, which gives me 6, and bottom times bottom, which gives me 7. On problem 5, when I look to my diagonals, I notice that there's something that goes into 2 and into 4, and that's 2. 2 goes into 2 once, so I reduce that to 1, and 2 goes into 4 twice, so I reduce that to 2. When I look at my 3 and my 5, there's nothing that can be reduced, so I'm going to leave it as is. So top times top gives me 5, and bottom times bottom gives me 6. When you get to problems 6 and 7, you'll notice that now we have mixed numbers. The first thing that we want to do is we want to change any mixed number to an improper fraction. So I'm going to do 4 times 1, which gives me 4, and then we add in the top. 4 plus 1 gives me 5, so I have 5 over 4 times 1 over 9. Then I follow my rules for multiplying fractions. I look to see if I can reduce. The 5 and the 9 do not reduce, so I leave them as is. The 1 and the 4 do not reduce either. So now I do top times top, which is 5, bottom times bottom, which is 36. Number 7 is very similar in that we have to change this to an improper fraction. 3 times 2 is 6. Plus 2 is 8, so I've got 8 over 3, I leave my denominator the same, times 1 over 2. When I look at my diagonal, 2 goes into both 2 and 8, so I'm going to reduce them. 2 goes into 8 4 times, and 2 goes into 2 1 time. 1 and 3 can't be reduced, so top times top gives us 4, and bottom times bottom gives us 3. You'll notice that what we have here is an improper fraction, so we ask ourselves, how many times does 3 fit into 4? It fits in there 1 time. We have 1 left over to get to 4, and we leave our denominator the same. Now we're going to move on to dividing fractions problems, and this is what we had said in class. Dividing fractions, easy as pie, flip the second and multiply. And what this means is we always have to flip the second fraction into its reciprocal, and then we multiply. If you look at this first fraction, what I'm going to do is I'm going to flip the second fraction. So instead of 7 over 4, it becomes 4 over 7. I'll change my division to multiplication, and I leave the first fraction as is. So now I can look at my diagonals. 4 and 5 do not reduce, and 1 and 7 do not reduce. So now I can do top times top to give me 4, and bottom times bottom to give me 35. Number 10 is a little bit tricky because 2 is not a fraction. So I'm going to first make 2 into a fraction before I flip the second. So now I'm going to go ahead and flip the second fraction to 1 over 2 and multiply. 5 and 1 can't reduce, 9 and 2 can't reduce. So when I do top times top, I get 9, and bottom times bottom, I get 10. For number 11, I've got to change to improper. 11 times 3 is 33. 33 plus 5 is 38, so it becomes 38 over 11 divided by 11 over 1. We've got to flip the second and multiply. 38 and 11 do not reduce. 11 and 1 do not reduce. So 38 times 1 is 38. And we should remember 11 times 11 from when we memorized our perfect squares. We thought field goal posts. And 11 times 11 gives us 121. For number 12, again, we have to change to improper. 7 times 1 is 7. Plus 6 gives us 13 over 7. Divided by 3/4. Now we can't forget to flip that second and multiply. 7 and 4 do not reduce. 3 and 7 do not reduce. So now we have to multiply. Off to the side, I'm going to do 13 times 4. 3 times 4 is 12. 4 times 1 is 4 plus 1 is 5. So we get 52 over 7 times 3 is 21. 21 fits into 52. 2 full times, which takes us to 42, and we have 10 leftovers. On number 13, you'll notice we're going to change our train of thought again, and now we're going to go into adding and subtracting fractions. And in the song it says, when adding up or taking away fractions, don't be a hater. Bottom numbers gotta be the same common denominator. We have to have a common denominator before we can add or subtract fractions. Notice that I always list a part for multiples when we have adding and subtracting fractions. So I take the two denominators and I first figure out where they meet up. 7 goes 7, 14, 21, 28, 35, 42, etc. And 4 goes 4, 8, 12, 16, 20, 24, 28. And I see that these two meet up at 28. So what I do is I take it as something over 28 plus something over 28 equals something over 28. We have to ask ourselves, how do we get from 7 to 28? And we have to multiply by 4. So we also multiply 8 by 4 to give us 32. To get from 4 to 28, you'll notice we multiply by 1, 2, 3, 4, 5, 6, 7. So I'm going to multiply by 7. We should have memorized from our perfect squares, 7 times 7 is 49. So now we just have to add our numerators, 32 plus 49. I'm going to add that up off to the side. Gives us 81. And we have to figure out how many times 28 fits into 81. So 28 plus 28 is going to give us 56. I'm going to see if we could fit another one in there. 13, and that takes us to 83. So it only goes in 2 times. And then we'll have to see 81 minus 56 gives us 25 leftovers. Now we have to find the common denominator between 2 and 8. It goes 2, 4, 6, 8, and I already know that they're going to meet up at 8. So it's going to be something over 8 minus something over 8 equals something over 8. With this, because the second fraction's already over 8, we don't need to change it. To get from 2 to 8, we multiply by 4. So we also multiply the top by 4 to give us 12. Our rule for subtracting integers is keep it, change it, flip it. And 12 plus negative 15, since they're different signs, we're going to subtract. We'll get 3. And because there are more negatives than positives, we get negative 3 over 8. For number 16, we're first going to change this into a fraction. We're going to find our common denominator between 1 and 7. Anytime it's 1 and another number, it ends up being the bigger number. So they actually end up meeting up at 7. So it's going to be something over 7 plus something over 7 equals something over 7. Since the second fraction's already over 7, we leave it. We have to multiply by 7 here. So we get 21 over 7 plus 1 over 7 gives us 22 over 7. 7 goes into 22 3 times. That takes us to 21. We have 1 left over. On number 17, we have to find our common denominator. I remember from the last slide that we had 7 and 8. They ended up meeting up at 28, but I'm going to just double check. It goes 4, 8, 12, 16, 20, 24. Yep, 28. So we're going to do something over 28, in this case minus something over 28 equals something over 28. So we have to multiply this one by 4 to give us 32. Multiply this one by 7 to give us 7. 32 minus 7, we've got to borrow, gives us 25 over 28. If you have any questions on this before you have your checkup, please email me. My email is sullivana@milton.k12.wi.us.